So this video is to try and better explain day 47, number 4, where we're given a cosine of 80 and its decimal approximation, and we're asked to explain how to find the cosine of other various angles given what we know about cosine of 80. So what we're going to do now is start with, and I'm going to draw it nice and big, the unit circle. All right, so the unit circle is a circle. I've tried to draw it nice and big, but it's a circle with radius 1 centered at the origin. So that would make this point 1, 0. And that's usually our starting point with these, okay? So we always want to measure our angles starting at 1, 0. So if we look here, if we start here and we go all the way up to there, that's 90 degrees. And we want to go 80, so we're going to come back a little ways. So my angle should look like that, where this is 80 degrees. And the way we're going to find the cosine of that is, well, with right triangle trig, sine, cosine, and tangent, we're going to need to make a right triangle. So let's draw an altitude perpendicular line to the x-axis. There's my right triangle. And what I'm going to do is I'm going to take that right triangle and I'm going to blow it up over here. So I'm going to draw it nice and big, so we can just talk about this right triangle for a second. There's my 80 degrees. And it's a unit circle, right? So I know that my hypotenuse is 1. And what's a good thing to call that? Well, let's call the bottom x and the top y, just because it's kind of the x direction and the other one's the y direction. We just need variables to call them. It doesn't really matter what they're called. And what is, in this triangle, what is the cosine of 80? Well, cosine of 80 is adjacent over hypotenuse, right? So that must mean it's x over 1. So x is essentially cosine of 80. Not essentially, it is cosine of 80. And we know that cosine of 80 is 0.17364. So that is x. What does that mean? Well, if you notice, this x here is my distance from the origin, the center of the circle, out to where this vertical line hits the x-axis, right? So this distance is 0.173648 that they gave us, all right? So with this problem, I think it might be easier to think of things that way. So let's draw the next angle. The next angle is 100 degrees. So here we go. We're going to start at 1, 0 again. Boom. If I go all the way up to here, it's 90 degrees. If I go all the way down here, that's 180, so I don't want to do that. So I think I'm just going to go from 90 over a little ways to 100. So something like that. There's my, so this red is 100 degrees. All right, so if that's 100, if I go from here to here is 100, what about if I go all the way to here? It doesn't have to be 180 in a whole line, so from here all the way to here should be 180. So if I take off 100, what's left here? I think it's 80 degrees. So this little bit here is 80 degrees. So if I make my right triangle, boom, I know that hypotenuse is 1, just like this hypotenuse was 1. So what do I have? I have this triangle again. It's the same thing. And what does that mean about the cosine of 100? The cosine of 100 is what? Well, it's the same magnitude as the cosine of 80, right? It's the same magnitude, so it should be 0.173648. But if you'll notice, the 80 was in, the cosine of 80 is in the positive x direction, but what's happened now? Now that I've flipped all over here into quadrant 2, my x values are going to be negative. So that cosine of 100 is going to be a negative 0.173648. So we're going to call it a negative 0.173648. So now we're going to do the same thing with 260 degrees. Well, boom, 90, 180, 270. So I've got to come back a little bit from 270 to hit 260. So let's draw our angle in right there. And we know that let's see. If I went all the way to here, it'd be 270, but I went back to 260, so this must be 10 degrees. So this must be, you guessed it, there's my 80. So what have I made yet again? The same triangle. My hypotenuse is 1. So here, I've got the cosine of 260. Now remember, the cosine is just that x value, so what is it? Well, yeah, it's going to be the same as cosine of 100. It's going to be negative 0.17368. Same thing. So the last angle we're given is 280 degrees. So if we start here and go all the way around, that's 270. Then we've got to go 10 more degrees to get to 280. So what I'm going to do is draw that in right there. There's my 280 degree angle. Again, if I start from here and go all the way around, I'm not going to draw it because it'll get cluttered, but there's my 280. So if this was 270 and I go 10 more, there's 10 degrees here. What must this be? Another 80. They're popping up everywhere. There's my 80. So now I'm going to draw my right triangle. And look, those line up. That's kind of nice. My hypotenuse is 1 again. What triangle do I have? Yep, it's the same exact thing. So we've got cosine of 280 is going to be... Now, I think we're going to agree that it's going to have the same magnitude, right? It's definitely going to be 0.173648. But is it positive or negative? Well, if you'll notice, this is definitely in the positive x direction, right? So it should be the same value as that cosine of 80. So it's just going to be 0.173648. That's all there is to it. So you'll notice there's a periodicity with sines, with the trig function, sines and cosines, because we've got here, we've got the same value right here, and then the same magnitude pops up here, but it's negative, and then another one here, and then look, the same value comes back up again as we go around this circle. So things repeat in these, and when we see the graph of it, it actually looks really neat, but we're not there yet. So now for the last part, what I'm going to do is I'm going to shrink all this and move it off to the side, and what I'm going to do is draw a new circle, and there's my new circle. And we've got, let me get some axes in there. We'll do our best to get them through the middle. Boom, boom. All right. So now what we're dealing with is we're dealing with the last part is the sine of 190. Now, okay, so it's a little different than the ones we've seen before, but nothing we can't handle. First, remember, we're going to start here and measure out 190 degrees. So there's 180, and we'll go 10 degrees more. Okay, so it's going to look something like this. All right, that's a little different than what we've seen before. Not to panic. Let's see what we can do. So if that's 10 degrees, now remember this whole thing, boom, that whole thing is 190. But that little chunk is 10, so what's left in here? 80 degrees again. So what I'm going to do now is a little different. I'm going to, no, actually, let's do the same thing. We'll just draw a line right up there. Boom, boom. All right. Now let's take this triangle and blow it up like we did before. Boom. There's that same triangle. I'm just making it bigger. And remember, we said this was 10 degrees. So, and my hypotenuse is 1. We know the hypotenuse, right? Still a unit circle. So if that's 10 degrees, what must this angle be? There's my 80 right there. All right. So let's look at what the sine of 10 is now, right? That 190, we turned it into our right triangle. So let's call this our x and that our y like we did before. So what's the sine of 10? Let's see. Isn't it going to be sine of 10 is going to be opposite, which is y, over hypotenuse, which is 1. So, okay, so in our new triangle there, where I've labeled them x and y, remember, it's different than the ones above. We've got sine 10 is y. Okay, that's good to know. But let's use what we learned before. Remember, it said for all of these to base kind of our new findings off of what we were given, the cosine 80. So since I see an 80 in my triangle, let's just see what happens if I do cos 80. Let's see what cos 80 is. Well, it's going to be adjacent over hypotenuse, so isn't that just going to be y over 1? So isn't cos 80 equal to y. So what do we think about the sine of 10? Well, the sine of 10, check this out. If the sine of 10 is equal to y, and the cosine of 80 is equal to y, I think we're going to find out that the sine of 10 is equal to the cosine of 80. And now you might be saying, well, how does that help answer our question? Because they're asking us about 190. Well, check this out. So this triangle is what I pulled out of this diagram. So that 190 is right here. Boom. All right. So what is the sine of 190? It's going to be this y value here, right? This y value. But we just found out that since the sine, now this 10 here is just because I've changed it to this triangle, but we're going to get the same value, I promise. So that sine 10 is going to be this same cos 80 value here. So we know it's that same magnitude. So here, I'm going to write this over here. We know that the sine of 190 is going to be, now I'm going to leave a little space here because we're going to have to talk about this for a second. It's going to have something to do with this 0.17364.8. But remember, we're talking this value here, which is this here. If I'll draw the y in, it's that distance. Well, if we are on the Cartesian plane, which we are, is that a negative value or a positive value? Well, I'll give you a hint. It's in quadrant 3, right? So isn't everything negative in quadrant 3? Yeah, that's a negative y value. So we're going to put a big minus there. So the sine of 190 is the opposite, the negative of the cosine of 80. So I hope that helps a little bit with these sine and cosines. I know it's weird to see things repeat, but just keep in mind drawing those right triangles out really, really helps for these.